Without any further ado, then I will bring up our first speaker, Shweta, to talk about container constructs. Hi, Shweta. Good morning, good
Hey,
afternoon. I know it's a late afternoon for you, I think. How are you doing today?
I'm doing very well and nice to see you, Madhu. It's your morning, I believe. And hello to everyone who are
Yes,
online.
yes.
Excited to be here.
Cool. Thanks, Shweta. I'm glad to have you on board. And yeah, probably in the intro video, you're going to talk about yourself and the container constructs. What do you want to talk about?
Okay, so let's get started with the topic container security must know constructs. What we are going to cover in this topic is container revisit. It's very important that let's understand containers once again, that what entity we are talking about. Post that, we'll see that we'll do some fun and we'll break some security myths. And the last, we'll build the security foundation, in which we will cover 4 must-know constructs for containers. So let's get started. Containers are build once and run anywhere entity. This term is very famous for containers because this truly defines that any container is self-sufficient, which means that it is created in such a way that bundled in such a way that all its application, libraries, configuration are bundled up in one packet. And this is self-sufficient, isolated, and it can run on any environment. So that's where we say that containers are the entities which are build once and run anywhere entities. What additionally I want to tell you that containers are not a bubble somewhere. They also run on very much on host systems. So containers have similarities with VMs as well as processes. How? I'll show you. From inside, if you look at the container designs are much similar like a VM. If you look at this right side picture, it indicates here that any host OS further gives us the VMs, which are partitioned on the guest OS, and they have their own application and binaries and libraries to it. Similar to that, containers also are bundled in such a way that they run directly on the host OS, and they have there this orange and yellow boxes which you are seeing are the binaries and applications which are bundled along with these applications. And what they need minimal is any container runtime engine, which in this case is Docker, but this can be any other container runtime engine, for example, Cryo, Containerd, or any other one. So that's how containers are though isolated, but they also share OS and wherever appropriate, their binaries and libraries. Let's see it in action. Here, what I have done is I'm just running a simple new pod with the image Nginx. Once it starts running, I have opened up a shell for that. So by bin bash shell, I have opened here. And the command which I'm issuing here is df-h, which indicates disk free and in human readable form. What this command gives me the output allocated size, where they are mounted on disk. So this is different from what VM has. VM also has its own chunk or share on any host system. My container also has similar kind of share of the host system or the kernel. Similarly, as you see, /bin, if we do, it has its own set of commands and libraries which it also utilizes. So that's how we can say that container in an indicative form is similar to a VM from inside. But container is also similar or is a process from outside. How? Because if you look at this picture now, the real process, which has its own memory, registers, and processes associated with it, it also has its libraries and binaries which are associated here. The only difference between process and container is that for any other process, it is bundled not in a containerized form. It is not tightly coupled along with the process, but it is shared among many other processes. However, in case of containers, it is limited with some limitations which we put, and we will see that how those limitations or the isolations come rather than limitation. Those isolations being achieved is that we pack all these libraries and binaries inside that container, and that's how it is maintained. But ultimately, this is also a process. Let's see how I'm relating it to a process in practical. So if you run on any system where you have some containers running, let's say I have running here Docker PS, it gives me container IDs, all the container IDs. And if I pick up any one container ID here, what I'm doing is I'm inspecting Docker inspect in the format state.pid. So what I'm trying to fetch for this container ID, the process ID internally hidden but associated with this container. So it gives me 3551, as you can see. And this is the process which is associated with it. So it's hidden. It has one more layer of abstraction to it, which is in form of container ID. But ultimately, this is also a process. Now, we have understood that container is build once, non-anywhere entity. It is self-sufficient. It is isolated. It is similar to VM. It has properties of process. But then what? Is it secured enough? Is it secured enough that it cannot harm the host system? Or is it secured enough that it cannot, one container cannot troubled by any other container? So that's the security myth, which I want to break now. And let's have some fun before we understand that what are those security constructs which you need to know. So I'm jumping onto my terminal where my Kubernetes cluster is running. And what I'm going to do, I'm going to run 2 pods here. Let me increase it a little bit so that it is clearly visible. Okay, so what I'm going to do, I'm going to with an image, a simple Nginx image. Okay, so here it started creating. And let's see what is the status of the pod. It's running. So as you can see, my container is new pod is running now. What I'm going to do, just from the demonstration purpose, first I'll show you a normal container. I'm going to shell, open std in our terminal, and for my new pod, open me a binary which is bash shell. Okay, something wrong here. Okay, I'm missing a dash. So it has brought me to root at new pod. So I am inside a container now. And if I do ls minus l now, I have my available file system to me, that what all files, binaries, libraries I have access to. But if you notice here, I have all the ordinary things which a container should have access to are available to me. There is nothing like which I can do anything to my host system. But now, given this view we have, what we are going to do is, let's come out of this. I'm clearing my screen. Okay. We have understood that it is a normal container and it has all the normal stuff which are bundled up with this container. But what we are going to do now, we are going to run an abnormal container. Let me first show you that what I have. So here I'm writing a YAML file where I'm running a pod kind, and its name is myth breaker because we are breaking some myth here. And it is running again with the same simple Nginx latest image which is available. But what's special here is that I am mounting a volume inside this container, and I am naming it /Kubernetes. But the fun part is the /Kubernetes is actually I'm hosting from the actual operating system or the host system. I'm allowing that my etc Kubernetes should be allowed to be mounted inside my container. So that's what I'm linking here. On top of that, 2 additional features I'm enabling, which will make me privileged authority on the container. So that gives me rights, which is like security context I'm setting that privileged true. So I have more privileges than the normal container. And I'm also saying that do it on the master node, not on any worker nodes. Don't place my container on any normal worker node, but place it directly on the master node. So with these extra configurations, I'm running this pod now. So kubectl, quickly apply my myth breaker. And here it goes. Let's see if it is in action. Kubectl get pods. It is still creating. And now it is running. So as you can see, one, we have normal pod, new pod. And second is myth breaker, which we just created, and that is also running. Now let's enter into this particular pod. And for that, same exec command I'll be utilizing, just that I'll be now moving into myth breaker pod rather than the new pod. Yes. So here I am inside root at myth breaker, as you can see. Now what I'm doing is same ls-l, list me all the files which are available to me. And here is the interesting part. I have access to Kubernetes folder, which is nothing but, let me clear the screen, which is nothing but, if I look at ls/Kubernetes, then it has all the contents which are there in the host /etc/Kubernetes. And it has PKI, which means all the certificates are now exposed to this container, which are actually residing somewhere in the master node. Then you have all the manifests which are running on the through the master node. You have kubelet configuration access. You have admin configuration access as well. So let's look at what is there in this admin conf, because that's the key. Sorry, PI won't work here. So I would say cat. Yes. So here my whole cluster information, my certificate authority, my server information, and whatnot. So everything is there at the back of my hand. So I can do whatever I want to do with this data. And that's what I wanted to show you, because we have played around, we have misused container capabilities, and because there are no security boundaries defined around that container. So that's why I'm able to break it and enter into that container with some more privileges, which is actually a wrong thing to do. And that's what I wanted to show you. So let's come back. Now that we have understood containers, though they are isolated, though they are packaged well, but they have got certain authorities which, if misused, can be bad for the host system or for the other containers. So that's what we want to secure from. Now let's enter into that. How do we do it? There are first 4 must-know security constructs which every technical person who knows about container and Kubernetes should know. First of all, this is SELinux. Second is namespace, Cgroup, and Seccomp. So let's discuss them one by one. All these 4 constructs, good thing about them is that they are free. They are freely available to you as part of the operating system features itself, which you can utilize, only that you need to know and be aware of them and make use of them. So let's get started with SELinux. Now, excuse me. SELinux is security enhanced Linux, as the name suggests. Basically, it is an access control mechanism. What it does, it labels everything. Basically, the good thing about SELinux is a very simple kind of feature, OS feature, a kernel feature, which is available to us, that it labels all your files, all your containers, and all the resources which they consume. So that's how it matches that who is authorized to utilize what resources. And that's how it restricts if I'm not authorized to use, let's say, host file system, then it won't allow to do it. Now, what it does, it protects processes from each other, protects host system from running processes. It protects the host file system from container misuses or vulnerabilities. So there are a lot of vulnerabilities which are easily you can catch with SELinux if enabled. For example, this CVE 2016-9962, which is a run C exec vulnerability, was found and it was caught by SELinux. So now that we have understood security enhanced Linux is a feature, OS feature, we can make use of it. But to make use of it, you need to make the conditions on so that SELinux is activated. The condition which is required is SELinux in this file /etc SELinux config should be enforced. The middle option you can see, it shouldn't be disabled, it shouldn't be permissive. Permissive means it is there, but it is not enforced. So that's also not a good thing. What we should do is SELinux enforcing. Now, it's very easy to disable this option and work because it at times when enabled, it gives you a lot of pain because it doesn't allow you to do anything wrong in the system, but this is good for production systems. And in general, we should make our developers and ourselves habitual of it to make use of it. So this is one way of enabling it. Second way of enabling it, set enforce. If you say 0, it will disable. If you say 1, it enables it. Or another way is get enforce. So this is what you can use. And if you are interested in knowing a little more about SELinux and want to see that what is the kind of labeling it does, use any of these commands. But to use these commands, one thing is important that SELinux toolkit should be there, as well as it should be enabled in the system. So once it is enabled and system gets time to catch up on labeling action by doing the restarts and all, it is able to label all the things. So you can see all those label by using, for example, ls-lz. That will show you what all labels SELinux put and how it protects. So this is one service which is very easy to use. Just you need to enable it in the background and it does its job very beautifully. Next, and very important feature which is linked to any container is namespace, because that's what brings the process isolation. So all that magic of isolation we associate with containers, that comes from namespace. Because namespace is kernel can isolate specific system resources usually visible to all processes. Now this is done by placing the resources within a namespace. That's what the job namespace does. Inside a namespace, only processes that are member of that namespace can utilize those resources. So it's a kind of envelope which you create and hide all the resources inside it. Then if you associate various processes or containers inside it, all those will obey the containerized environment or the namespace limitations which are associated with it. Namespace also helps you apply security restrictions to containers. We will see how in a moment. Before that, one important thing I want to tell you that there are 7 such namespaces, which are Cgroup. We'll be talking about it. IPCs, which tell you, which helps container to know that what process communication is possible among the containers or outside. What is the network allocated to it? What file systems can be mounted? What is the process IDs associated, users, group IDs, and host names. So these are 7 namespaces which you should be aware of. You need not do anything about it, but you should be aware of that these are the 7 namespaces which actually are associated with each and every of your container. And they have their own instances of these 7 namespaces inside it. And that's what enable your containers to make use of host system resources, be it CPU, be it memory, or any other thing. So that's what is important to know. Now, to see this in action, just give LSNS command, which means list all the namespaces. And in the type column, you can see that all those 7 categories which we just saw are labeled here. So it is either Cgroup, PID, user, UTS, IPC, and mount. So all these namespaces which are there and in action are out of those 7 only. Let me also tell you about the container namespace protection. I'm just showing you 2 of the ways, but there are many other ways that can work around namespace. For example, here we are defining a policy where we are saying that user LS can work only in namespace fronto. Resource pods can be utilized read-only nature. So only we are enabling it to read certain resources or utilize whatever is required for in read-only mode. So that kind of policy can be associated with namespaces. Similarly, for any namespace, you can also at the from the hierarchy perspective, namespace level, you can define wherever inside you have your pods or the containers defined. You can say that how much of CPU and memory can be overall consumed by my namespace. This is to restrict that beyond this limit, my containers should not be able to eat up on my resources or the host resources. So these are 2 of the ways, but there are many other network policies and other things where you can include the namespace and it restricts the containers. So this control group is very important namespace construct because control group is the one which actually limits at the runtime that how much of CPU and memory you can utilize. So this comes into the action. This is another namespace which is associated with your container or a pod, and it comes in action at the runtime. So it makes CPU aware that how much of containers can utilize. Container options, some of the container options, as you can see, that CPU share, CPU set CPUs, and some more things, which in practical way, we don't utilize it we can set it if we want, we can set it from command line or through YAMLs, but usually we don't touch that. We don't touch those things. We have pod restrictions or inside the pod, you can have your limits and the resources defined, and that's what take care of that you will be limited by the resources. But you should be aware because Cgroup is something which was created, if I'm not wrong, in year 2006 or so by Google, and they named it as process containers. That was the idea behind that. How do you limit your containers and still this works as a process? So this is one key feature behind the scenes which you should be aware of. Next, and very important feature is Seccomp. Seccomp stands for Security Computing Mode, but I'll come to that. However, this feature is related to your system calls, because whatever in Linux kind of system, any interaction happen, processes are able to achieve anything by using those system calls. And roughly around 400 system calls are there in total. However, each system call is a facility as well as can be source of potential attack on kernel or running processes. So we need to be very well aware that what system calls should be enabled for us. For any container program, 20 to 30 system calls potentially can be required, or even lesser. We will see in few moments that why it needs to be lesser. If containers utilizing more than this, then there is something really wrong with those containers, or somebody has increased their privileges, which can be very, very harmful for the system. So we need to be very well aware of it. All in all, Seccomp is security mechanism to restrict these system calls that a program may make. Let's understand it in little more detail. As I said, Seccomp stands for Secure Computing Mode. Now, the main page definition says that it itself is Seccomp system call operates on the secure computing state of the calling process. Seccomp limits how processes can use system calls. Of course, that's the main purpose, because secure computing mode tells you that how much of system calls you are authorized to make, and that's what it limits. It defines security profile for processes, whitelist the system calls, parameters, and file descriptors. Seccomp defines which system calls should and should not be allowed to be executed via containers. And that's where we are relating it to container, that what containers are allowed to do in their isolated mode and what they are not or should not. It restricts the calls a process or container able to make from user space to the kernel space, because we don't want to exploit the system. But if you remember, we misused in our demo by enabling ourselves to privileged mode, and then we actually utilized more system calls which were available to us, which is not a good practice. Let me first show you in kernel context. If you simply run this command, cat/proc sys-kernel and cap last cap, so that will give you the number of system calls enabled at the moment for your kernel. If you want to see them, if you're interested in knowing more about them, then they give this command cap-sh --minus print, and it will give you all the bounding set which is currently operating for your kernel. So as you can see, all these comma separated, but all of them start with cap underscore, for example, chown, DAC override, cap net admin, and there are many more. So I'm not going to talk about every one of these, but just to show you that what is enabled for us. Now, if you are interested in knowing that for your process or your container, what are the capabilities or the Seccomp capabilities which are there, then just give cat/proc process ID number, where in this case 94 is the process ID number, /status, and just grep on the cap. You will see 5 parameters coming. First one is capabilities inherited from your kernel or your host OS, capabilities permitted, capabilities effective at the moment, and bonding set and ambient. We are not interested in all of them, but permitted and effective. And if you pick up any of these permitted or effective and decode it with the cap-sh --decode and this value, then you will see that for this process, how many of capabilities are, or the system call capabilities are enabled at the moment, which may or may not be desirable. That's what we want to restrict on. Now, relating it to containers, because we are talking about all premises around the containers. In containers, there are 2 ways to define it. You can say that in your spec security context, where Seccomp profile should have runtime default, where whatever is defined by my system, I'm just inheriting it. That is one way of doing. Or second way of doing is that I don't want all those 37 to be available to me, right? 37, 40 or whatever is available to my host or kernel. So I want to restrict it, and very minimum one which I want to expose to my container. So you can have your local host profile defined, where you can say profiles, fine-grained, or whatever name you want to give, .json, and just mention the capabilities which are required, and it will do the needful. Okay, so here we come to the end of this discussion, but just winding up quickly on this, we saw that containers are isolated and self-sufficient units, but it doesn't ensure that they are secure from other containers or they are not doing any harm to your host operating system, because ultimately they are running on your same operating system where other things are running. So you need to be aware of these 4 constructs, which are free of cost, and you can make use of these things. First is SELinux, which just by enabling And once this whole thing runs and labeled the system, it takes care of all the vulnerabilities or all the excess issues which may occur through vulnerabilities or through programming errors or whatever. It restricts all those. Second is Seccomp, which is a system call mechanism where it restricts that processes can use which all system calls at the runtime. And this can be restricted not to too much empower our containers, and this should be utilized. Then namespace is the process or container wrappers, as we saw by having those 7 namespaces. There are various privileges or various features associated with namespace where you can define policies, you can restrict through namespaces, and you can make sure that your containers are utilizing what they are supposed to be utilizing, not anything more than that. And Cgroup is the feature, which is again a namespace, but it works behind the scene and it makes sure that your CPU and memory are used honestly or legitimately by any container or a pod. So with that, I come to the end of this session. Let's look at the questions.
Cool. Thanks, Shweta. Well done. Well done. That was a very interesting and insightful session. Thanks. I would like to bring the questions on the screen. So if you could answer them. The first one is from Mohammed Amar. He asking basically, what does security contest privilege do? I mean, does it go unwanted, give unwanted rights to the container on the host?
Yes, certainly. So, Mohammed, what happens when you say security context to privileged? Uh, when you before coming to privilege, when you create a container file, when you define that, okay, I'm creating a container file, it will have these libraries or what I'm packaging from my application. By default, system associate root access to that, which is at some level. Now, when we say in our YAML file on top of when we are running it on Kubernetes container orchestrator or Kubernetes platform, if we are saying privilege, that is even more than the root privileges. So, which means if at the definition level you are saying root for some reason, and when you are creating your YAML file and you are taking it to privilege, it means you are even enhancing their capability. And it can be definitely, I mean, using this, we saw that we were able to get into the host operating system and get all the admin configurations, all the certificate information, encryption information, etc. So definitely it is harmful. And how to restrict it, that's very important. I mean, the best practice says that if you can restrict it at the time of defining your container Docker file itself, be very specific and say that so and so user and so group should be able to do all these operations which you are defining in Docker file. So that is the best practice. But at times you need to give root, but definitely go away with the privilege and make it a practice in your projects that don't use privilege security context. Hope that answers your question.
Cool. Thanks, Shweta. So we have another one from Mohammed again. So he's basically asking, when you say we have enable SELinux, so are you talking about enabling in the host system or in the container?
Okay. Yeah. Good question. See, SELinux is a operating system construct. So you don't enable or disable it at the container level. So definitely you need to take those commands which we saw. You need to enable it at the OS level, and then it has various authorities, container underscore T, and various other labels which it associates at the container level. It does its job because for SELinux, it's like any other process and any other files which are associated with that process. So what container is able to utilize and what resources it should consume, by labeling and matching those labels, SELinux does its job, but it is at the OS level. So that's the
Cool. Thanks,
answer.
Shweta. Good answer. Good answer there. Sure. Cool. So there's another question from Anthony. He's basically asking, can these tools be added to AWS hosted containers? For example, I mean, I can extend a little bit. We have Elastic Container Service, a Kubernetes service in the hyperscalers, right, or Azure or GCP. Can we add these tools in those cloud native way or any other way?
I'll tell you, based on my experience, I might not be able to fully say that yes, it is. You can do it for ECS or Fargate or all those things. But when you utilize AWS EKS service, and if underlying host you are taking is Red Hat Linux, or if you're not going with EKS and you're going with AWS ROSA service, then yes, certainly, because Red Hat OS has this feature by default, but you need to enable it as we discussed. But I would need to check if you go with AWS Linux whether you can do it or not. I think I have not checked that. But I mean, logically speaking, it's a Linux platform. You should be able to use it. But if EKS brings its own dependencies or restrictions, that is something I am a bit conscious about and would not like to say that everywhere you can use it.
Yeah, sure. Yeah, thanks, Shweta. Thank you. Just looking at the chat again. So, are there any other questions from anyone? Please feel free to add because still have some time for Shweta for the questions. Uh, yeah, just to extend a little bit on this AWS hosted containers. Any managed service you take from hyperscalers, the underlying infrastructure is completely managed by the hyperscaler itself, like AWS or Azure. So you will not have a full privilege on how they run. For example, on the control plane level, you just have access to the control plane, but you don't have access to the server where the control plane or Kubernetes server is running. Yeah, so they give you an endpoint, and then basically you can play around. You will have full access to it, to how you want to run it. So there might be some certain limitations what and how you could do, but I'm also not sure if you could implement these tools on a cloud native way. But yeah, good question there. Thanks, Anthony.
Yeah. Good question. Yeah. Okay.
Okay. In that case, Mohammed is happy with your answer. Thanks, Mohammed. uh, cool. Is there anything else you would like to add, Shweta, from your side? Like, we talked about containers, we talked about cgroups, we talked about this four important constructs. What is that? What is the takeaway from your talk, right? So, what is that guys have to take away from your talk? What are the key factors that you would like to pass the message?
Good question. Good that you're allowing me to summarize it, Madhu. That I would say that container, we discuss it's isolated, it's self-sufficient, but it has layers to it. It runs on some infrastructure. So definitely security also comes in various layers. But I believe if you know that how container is a container and not any general process, that is very much essential for you to know so that you can save it from the external world or save a container to do any harm to your operating system. That is one point which I tried explaining in my talk. And second aspect is these four constructs which I spoke about today, and specifically I wanted to do that because these are free of cost and you can use it very easily. And you need to be aware whatever security tool you put on top of it, which is paid or unpaid, these are something which will play under the scenes. So it's always advisable that be very well aware of that what can happen to your system at the container level. So that's the summary in nutshell.
No, that's a good message. Good message. Yeah. So fix the problem before it even occurs, right? So yeah. So yeah, that's a great message, Shweta. Thank you. I don't see any other questions in the chat for you. And yeah, that's a fantastic talk. I learned myself as a container guy. I definitely learned some new aspects in those constructs and more technical deep dive. So thank you, Shweta. It's a really great insight and very well done. And thanks for the audience who asked the questions as well. Thank you, Shweta.
Yeah. Thanks.